liquid pressure using manometer. Many techniques have been developed to measure the pressure of liquids. The instrument used to measure pressure is called a pressure gauge or a vacuum gauge. Manometer is one such instrument used to measure liquid pressure. Manometer was invented by Christian Huygens. Let us study the working and construction of a manometer. Construction. A manometer consists of a U-shaped glass tube fixed on a stand. There is a scale fixed on the same stand with graduations marked vertically on it. The U-tube is half filled with water. One end of the tube is attached to a thistle funnel through a flexible rubber tube. The mouth of the funnel is covered with stretched rubber, like that of a membrane stretched on a drum. The other end of the U-tube is kept open. Let us label the side with the thistle funnel as A and the open end as B for convenience. Working. The atmospheric pressure acts on the open end of the U-tube. The same pressure acts on the end of the thistle funnel when kept in air. Hence, the pressure on both sides of the rubber tubing are equal. Therefore, the water level in the U-tube remains the same on both the sides. Now, if the stretched rubber skin is lightly pressed with our fingers, the pressure on it increases. As a result, the water level in A goes down and the water level in B rises up. The difference in the water level gives a measure of pressure exerted on the rubber skin, which can be read on the scale. This manometer with one open end is the simplest and the oldest type of pressure gauge. Let us do a quick check. Atmospheric pressure. Atmospheric pressure. Atmospheric pressure. We know that a layer of air surrounds the earth, and that air is nothing but a homogeneous mixture of gases like nitrogen, oxygen, water vapor, carbon dioxide, and other gases. This envelope of air is known as the atmosphere. The atmospheric air extends up to as many as 120 kilometers above the surface of the earth. The pressure exerted by the atmosphere is known as atmospheric pressure. Now, let us try to estimate how much pressure the atmosphere exerts. Let us imagine a column of air of height 120 kilometers and an area of cross-section 1 meter squared. What would be the pressure exerted by this column? Atmospheric pressure is the weight of air in a column of unit area. Assuming that the area of a person's head is about 10 centimeters into 10 centimeters, which is equal to 100 centimeters squared. The weight of air in a column of height 120 kilometers would be as large as 1,000 kilograms. But we are not crushed under this weight. The reason is that the pressure exerted by the fluids in our body cells and by the blood in our capillaries is almost equal to the atmospheric pressure. However, this pressure exerted by our body acts in a direction opposite to that of the atmospheric pressure, and therefore nullifies the effect of tremendous pressure of the atmosphere acting on us. Atmospheric pressure decreases as we move from a region at low altitudes to a region at higher altitudes. That is why when we travel by aeroplane, our ears ache due to a decrease in the atmospheric pressure at same way, when the aeroplane is landing, the increase in atmospheric pressure affects the eardrum, making her ears ache. Atmospheric pressure plays an important role in causing land and sea breezes. Unequal heating of air over land and water causes change in air pressure. This results in breezes near shorelines. These are called sea and land breezes. During the day, the land is warmer than water. A slight variation in pressure is caused by this temperature contrast. Air above the sea is at a higher pressure and moves towards the land. As the wind moves inland from the sea, it is cool and moist. This is called the sea breeze. As the sun sets, cooling begins along the surface of the land and sea. Like daytime heating, cooling occurs at different rates over water and land. The rapidly cooling land soon creates a higher air pressure overhead relative to that over the sea, and the air begins to flow down the pressure gradient seaward. This is the land breeze. Atmospheric pressure has tremendous strength. In order to understand more about air pressure, let us observe the given activities. Take a good quality rubber sucker. It looks like a small rubber cut. Press it hard on a smooth, clean surface. What do you observe? When you press the sucker, most of the air between its cup and the surface escapes out, thus creating a region of low or negligible pressure there. The higher atmospheric pressure outside the sucker acts on the cup of the sucker and pushes it in. Consequently, the sucker sticks to the surface tightly. Now, try to pull it off the surface. Does it get pulled easily? No. It is difficult to pull it out. To pull the sucker off the surface, the applied force should be large enough to overcome the atmospheric pressure. We are now in a position to understand the vast range of application of pressure based on the various effects produced by it. Atmospheric pressure acts on an object equally in all directions. There is one more interesting effect produced by atmospheric pressure. Let us perform an activity to understand about it. Take a can made of thin metal sheet with a screw on the lid. Pour a little water in the can and heat it till the water begins to boil. When some steam comes out of the can, close the lid tightly. Stop heating and allow the can to cool. What do you notice? It is amazing to see that the can gets crushed from all sides. Let us try to understand what actually happens. As the steam starts coming out of the can, most of the air which was trapped in the can gets expelled out. The steam occupies the space thus created. On cooling, the steam condenses into water, creating a partial vacuum in the can. Thus, there is a remarkable decrease in the pressure inside the can as compared to the pressure of the atmosphere, acting on all the surfaces of the can from outside. As a result, the can gets equally crushed from all sides. We can thus conclude that atmospheric pressure acts on an object equally in all directions. Otto Walker demonstrated the great force of air pressure. Otto Walker, a German scientist of the 17th century, invented a pump to extract air out of a closed container. With the help of this pump, he dramatically demonstrated the force of air pressure. He joined two metallic hemispheres, each of diameter 51 centimeters, and pumped air out of them. It was indeed very difficult to pull the two hemispheres apart. Then he employed 8 hoses on each hemisphere to pull them apart. Alas, so great was the force of air pressure that the hemispheres could not be pulled apart, even by the combined strength of 8 hoses. Can you demonstrate the strength of atmospheric pressure? Let's try this by performing an experiment. Take a glass filled with water up to the brim and place a square piece of flat and stiff card paper on it. Holding the card paper in place with your palm, carefully turn the glass upside down. Take your hand off the card paper. Now, get ready to view the magic. Water from the glass does not spill at all. How did this happen? It is because of the atmospheric pressure acting on the card paper in the upward direction. As this pressure is much greater than the pressure exerted by water in the glass acting in the downward direction, the water in the glass does not spill. Now, did you get a feel of the tremendous strength of atmospheric pressure? Applications of atmospheric pressure. The effect of atmospheric pressure can be observed in many activities of our day-to-day life. For instance, when we drink temperature water with the help of a straw, we suck in air from the straw. This reduces the pressure of air in the straw. It is the atmospheric pressure that forces the drink up through the straw. Also, while blowing a candle, we pucker our lips to decrease the area. This leads to the increase in the pressure of the air thrown out of our mouth. The air escaping from our mouth thus has high speed, due to which the flame of the candle blows out. In our day-to-day life, we use many devices like an ink dropper, spray pumps, syringes, air brakes, etc., all of which work on the principle of air pressure. Let us see the working of an ink dropper. Have you observed an ink dropper carefully? It is generally made of glass or plastic and has a tapering end with a narrow opening. There is a small rubber bulb fitted at the other end to hold the dropper. When you dip the narrow end of the dropper in the ink bottle and press the rubber bulb, some air in the tube is pushed out. This decreases the pressure of air within the tube. Now, when you release the rubber bulb, the atmospheric pressure acting on the ink pushes it into the dropper as the fluids flow from a region of higher pressure to a region of lower pressure. You can see the ink rising into the dropper. This happens till the pressure inside the tube is equal to the atmospheric pressure acting from outside near the narrow opening of the tube. Due to this, the ink does not spill out when you take the dropper out from the ink bottle. To fill this ink in your pen, you will hold the narrow end near the open barrel of the pen and press the button. The ink flows out. Why do you think the opening of the ink dropper is made so narrow? Well, this has two benefits. Firstly, the narrow opening of the ink dropper offers very small area, thus increasing the pressure near it tremendously. Hence, even if the quantity of the ink in the dropper is small, the pressure inside the dropper increases to become equal to the atmospheric pressure outside. Secondly, the narrow opening makes it easier and convenient to pour the ink from the tube into the pen without spilling it. We can say that the dropper is a kind of pump. In the same way, the cap of a bottle containing liquid iron drops has a dropper with a bulb so that the medicine can be conveniently dropped into the irons. Another familiar device based on air pressure is a spray pump. The spray pump is used for spraying colors, while being holy, you call it pitchcraft. A spray pump is also used for spraying fertilizers and pesticides in fields. Working of the spray pump. How does the pitchcraft work? Take a spray pump and observe it carefully. You will note that it consists of a cylinder made of plastic or metal, which tapers in the form of a narrow tube at one end. The other end of the cylinder has a lid with a hole in its center. A piston, which can be moved up and down, is made to fit snugly inside the cylinder with the end of a rod passing to the hole in the lid. This rod has a handle attached to it. To fill the pump with colored water or any other liquid, the narrow end of the pump is placed in the liquid. The piston is then pushed down towards the tip, up to the bottom. This makes almost all the air to escape through the tube. As a result, there is a decrease in the pressure inside the cylinder. Now, when you pull the piston in the upward direction, the liquid rises into the part of the cylinder below the piston due to the atmospheric pressure acting on the liquid from outside. After some time, you notice that no more water enters in the tube. Also, when the pump is taken out, the liquid does not flow out. Do you know why? This is because the pressure of water inside the tube becomes equal to the atmospheric pressure outside the tube. Now, what do you do to spray the liquid? When you wish to spray the liquid or the colored water on your friend, you push the piston in towards the opening of the tube, thus increasing the applied pressure on the piston such that it becomes greater than the atmospheric pressure. As a result, the colored water gushes out from a narrow opening of the tube in the form of a spray, and you see your friend all wet and colorful. It is interesting to know that a doctor's syringe also works on the same principle. Let us compare the working of a spray pump and an ink dropper. In a spray pump, a piston is used to reduce air pressure inside the cylinder before letting the liquid enter the cylinder, while in an ink dropper, a rubber bulb is used. In the spray pump, the piston is pushed towards the opening to spray the liquid, and in the ink dropper, rubber bulb is pressed to let the ink flow out into the pen. Working of air brakes. You must have heard a loud hissing sound of air whenever the driver of your school bus applied brakes to slow down or stop the vehicle. Where does this sound come from? Well, it comes from the air brakes fitted in your bus. Air brakes were invented by George Westinghouse and are used to control the movement of vehicles. Air brakes were first used by George Westinghouse on 5th March 1872 for the railway train. Air brakes are also used in other vehicles like trucks, buses, trailers, aeroplanes, etc. How does air brakes work? The air brakes consist of a cylinder filled with air and connected to the front as well as rear wheels of the vehicle. When the driver presses the brake pedal, the air in the cylinder gets compressed. Consequently, the pressure increases inside the cylinder. This causes the brake shoes to rub against the moving wheels, thus reduces the speed. Let us do a quick check. Measuring atmospheric pressure using barometer. Can we measure atmospheric pressure? Yes. A device called barometer is used to measure atmospheric pressure. The first barometer was invented by Evangelista Torresini, an Italian scientist, in 1643. A barometer consists of a glass tube sealed at one end with an open mercury-filled reservoir at the base. Vacuum is created at the top of the tube due to the weight of mercury. Mercury in the tube adjusts its height until the weight of the mercury column balances the atmospheric force exerted on the reservoir. If the atmospheric pressure is high, then it exerts more force on the reservoir, forcing the mercury level higher in the column. On the other hand, a low pressure allows mercury to drop to a lower level in the column by lowering the force on the reservoir. This is how the atmospheric pressure is calculated.